My name is Diana Marculescu. I'm a professor of electrical and computer engineering at Carnegie Mellon University. Most of my work relates to sustainability in computing, but also, more recently, computing for achieving sustainability in other fields. When something becomes more efficient, we're going to use more of it. Data from Cisco, for example, shows that for each person, there's at least 2 or 3 smart devices connected to the internet. And that number is actually exceeding right now. So we're not really going to achieve energy efficiency per se if we're actually going to use more of it, right? Because at this point, much of the energy still comes from fossil fuels. So one thing we'd like to do is use what we have for something that has a larger social impact, for aiding in renewable energy distribution and generation. The concept of sustainability, meaning maintaining forever a certain performance or behavior, actually exists in nature. So there is a certain jellyfish called Benjamin Button jellyfish, because it actually can turn itself under stress from whatever shape it is into multiple polyps that actually turn into young jellyfish. So in theory, they could live forever unless they're eaten by predators. So we're trying to replicate that behavior somehow. The same paradigm could use power-efficient computing systems to aid in renewable energy generation, which in turn would help power fabs that manufacture those exact systems. We all know about renewable energy generation, so wind, solar, hydro. For wind power, we use arrays of turbines. For solar, we use arrays of solar panels. But for water, we're still in the hydro dam paradigm. So the idea is to move away from that and try to use an array approach, where we could use these energy-efficient computing devices to actually determine the best balance between the demand from the consumer and what we have from the hydropower generation. So it's the best marriage between achieving sustainable computing and using those to achieve sustainability in renewable energy distribution and generation. We just started this project. It's funded by the National Science Foundation. We hope to have results in 3 to 5 years. We're working with specialists from pricing and energy and policy, as well as specialists from hydrology. So eventually, we're hoping to show that this is something feasible, so that could be used, for example, in addition to existing hydropower projects or new power projects in places where there wouldn't be enough resources to build a huge dam. And developing economies are one such example.